Users and subscribers, welcome back to one next edition of Greens Electrical School. I'm here in Kingston, Jamaica, in one of the ghettos in Kingston, one of the lower areas of Kingston. Yes, I'll be working from the ghetto today. We are here to repair a refrigerator. That is the freezer is working, but the bottom section of the refrigerator is not working, and there are few things that can cause that, and we're gonna investigate that right about now. I've already pulled up the panel. Normally this panel here has to bear with me. I don't have my camera crew with me today, so I'm videoing live from my personality here. Okay, so you have a panel that fits in over this, and once it's geared up, you have an X. Just a minute. You have an X fitting that goes over that cover there, and that controls the amount of air that flows into the freezer, and that circulate also down to the cooling compartment. So this panel that is exactly fits, and you can turn that min or max or whatever. But that is not the main thing we're here today. We're here to find out what is causing the problem, and we're going to show you that real quick in this video. Okay guys, so first of all, we want to understand how this refrigerator works, right? This is one of the later type model of refrigerator. I will soon show you the brand a little later on once we go on to the back of the refrigerator. But it actually works. A refrigerator works more like an air conditioner. It actually circulates a fluid we call refrigerant through tubes. These are the tubes it circulates through, coming from a thing we know as a compressor, coming up to the freezing compartment, and while it's running through this tube, this fan here actually spins, and what it does is circulate the air into the freezer compartment, and because the refrigerant is cold, really cold, then it causes the freezer to freeze your food. They actually absorb the heat from your food, put it into these coils, and it brings in cold air, making your food cold. And what it does, this little hole right here sends down the cold air, down to your cooling compartment down here, where you put your little sodas or whatever that you don't want to be frozen. Just cool food you need down here. Comes through this little hole down here, and it cools your food, right? So that's a basic thing that this actually does. All right. So a number of things can cause this refrigerator to behave like how it is behaving. The freezer is freezing and the cooler is not cooling. Number one, when I came here, it was like this. First thing I do is I just unplug the refrigerator, and one of the number one cause you could look for is a thing called frost buildup. Once you pull off the panel, you see a lot of frost here, a lot of ice. You see a lot of ice in the freezer, and many times this hole becomes blocked with ice, and then it cannot flow down to cool the bottom section of the fridge. All right, so that is not the case today. Okay, many times you see problem like this, you would love for it to be that case, but it's not so today. So what means it means we're gonna have to dig a little deeper. All right, so we're gonna go ahead and we're gonna test. Number one, what can happen? You want to check the timer. Each refrigerator have a timer that actually, whenever the fridge is running, the timer sets when it stops, because certain times the fridge stops to get rid of the amount of ice or the frost buildup on the coil, and what it does, it drains it into a thing at the back of the fridge I will show you in a short while. It drains it through the hole, and it runs to the back of your fridge as a result of a heating component. So this little thing at the bottom here is a heater. A lot of times whenever you have problem like this, the heater is malfunctioning. So we're going to test the heater a little later from now, and we're going to test some few other components as we go along in this video. Okay guys, so I am back at the back of the refrigerator now, and we just want to see, as you can see, this is a Black Star brand refrigerator. Okay, I'm sure you guys can see this. You have the brand name, General Bosch, and it tells you what kind of refrigerant it uses, and the power conservation, and you can see the circuit diagram here. See if we can get this a better view of this. I don't know if you guys can see that clearly, but it has a circuit diagram which tells you how all the electrical components work. But we won't be going through this in this video. I'm just gonna show you guys what the main thing to look out for. We do this understanding these kind of things in the next video. I'm just gonna show you the main things you gotta look out for when these kind of faults happen. All right. So I'm gonna go down to the back of the fridge now, way down to the bottom. Now the thermos, the timer is a switch, as I said earlier, that modulate whenever the fridge go into defrost or when the fridge runs. All right. So what we normally do, we'll take this a flathead screwdriver and we're gonna turn this. We're gonna plug in our fridge because right now the fridge is unplugged. We're gonna plug it in and we're gonna turn on our timer, and then once the fridge is on, then this compressor, this is the compressor right here, should comes on. This is the thing, this is the equipment that hoses the refrigerant and pumps the refrigerant around the circuit, and it should comes on, and then we're gonna turn it out of running and put it into defrost mode, and then that heating component within that freezer that I showed you guys earlier that melts the ice and drops it into this pan back here, this drain pan. It should come on once we take it out of run and put it into defrost. We're gonna do that right here. Okay, viewers and subscribers, now we're gonna plug in our fridge and we're gonna put that thing to run mode. Okay. Oh, it's already on run mode. So that compressor chips in right now. And we're gonna look what is going on inside the freezing compartment. All right. So that you can hear that compressor just chips in. All right. We're gonna check now what is happening on the inside. Okay, guys. So on the inside, we see that the fan comes on. All right. Normally, when you have a problem like this, the bottom of the fridge is not cooling, and that fan sometimes is jammed or is not working. So now we know that the fan is working, and if you can look closely at the tubes, they are actually being heated up with refrigerant. If you touch it, you can see. All right. So it's building up a lot of frost. So we're gonna let this run for a couple minutes, and then we're gonna come back and check on it to see if our timer is working efficiently, or beg your pardon, our heater is running efficiently. All right. So we're gonna let this build up a little bit, and then we're gonna come back and we're gonna check on it. You can see the frost coming up, meaning that our refrigerant is pumping through. All right. Okay, guys, welcome back. We see that the frost is building up in the freezer. Now what we're gonna do, we're gonna test this heater down here. We're gonna go back to the timer. We're gonna return it until we hear a certain click for this heater to come on to test if our heater is working. All right, these are just a few tests. I'm walking you guys through the process very quickly right here at Greens Electrical School. Okay, so we're at the timer now. We're gonna reset this. Now you're gonna take a little flat point screwdriver. You're gonna put it right at a little knob on the timer. You're gonna give it a turn. You should hear it clicking. We're looking for a big click. It's clicking now, but that's not the click you want to hear. That's the click. You hear that big click? Yes, it means it turns off the compressor. The compressor is now off, and now we're gonna look what's going on the inside. Okay. Okay, viewers and subscribers. Okay, as you can see, the fan has stopped, which means our timer is properly connected to the circuit. Now we want to know that whenever that timer stops, we want to ensure that it is operating the heater. So what we do normally, you don't want to put your hand too close to this thing because it gets very, very hot. You can receive a very nasty burn. So you put your hand a little close, or once it just started, not that hot as yet. So you put your hand a little close, and right now it's not fully hot as yet. So we're gonna give it some time to really get heat up, and we'll be back. Okay, guys, so we are back now, and if you feel that you don't want to put your hand too close, it's really hot now. You don't want to get it. If you to prove that it's really working, you can see the water dripping off those coils and going down to that drain pan. All right, so we know fully that this heater is working. So the defrost system is working perfectly fine. So in a case like this, you wonder and you start scratching your head and say, okay, what could be the problem? And, I've gone early and checked the airflow hole on here. There's no blockage. So you wondering to yourself, what is happening? You know what's the problem? Main problem in this kind of case, after doing your tests and testing the sensors and all of that, The main problem would be your refrigerant. So if your refrigerant is low, then what's going to happen? Then it isn't going to be enough coolant, or I should say, if refrigerator is not going to run cool enough to really support the two compartments, right? You found out that one section is cooling and one section is not. Reason being because the refrigerant is not cool enough. Each refrigerator requires a certain amount of refrigerant to keep it running. All right, so which mean our refrigerator is starving, I would say, for refrigerant. Oh, it's starving for refrigerant. Okay, so we're gonna have to add some refrigerant to this refrigerator, and how we do that, we're gonna have to know what kind of refrigerant this refrigerator uses. Okay, guys, welcome back to Green's Electrical School. So we're back at the panel of the fridge, and I do ask my viewers and subscribers to bear with me because my camera crew is not here today. It's very difficult filming this thing on my own. All right, okay. You see the part that says refrigerant, right? It uses a R134A, 120 gram. All right, that's the refrigerant that this refrigerator uses. So to add more refrigerant to this refrigerator, you have to get this same type of refrigerant for it to operate like it should. All right, and that's what we're going to be doing right here. Okay, guys, so we have got the refrigerant here, R134A. Okay, and it is 340 gram. And remember, on the back of our refrigerator, it uses a certain amount of grams. So already some refrigerant would have been already in the refrigerator. So I doubt we're going to add all of this. Okay, we're going to have to measure and do some calculations and see how much of this we're going to really have to add to it. All right. Also with my refrigerant, we have this valve here that actually screws onto this, and when we're ready to release refrigerant, it comes out. Okay. We have what we call a piercing valve, and we're going to use to pierce the copper tubing of the copper of the suction line of the refrigerator to add our refrigerant. We'll be doing that right about now. We're going to add this to the back of the fridge to connecting in the suction line for us to add this refrigerant. Okay, viewers and subscribers. Okay, so we'd have added a refrigerant to our refrigerator, and that refrigerator would have just pop in and it would be cooling down the place. So these are the necessary checks you would have performed to know that you're low on refrigerant. After doing the checks of testing the heater, you'd have tested the timer and the thermostat and all those stuff, and you realize that there's no frost building up, because remember when we just came there was no frost building up in the refrigerator. So there was nothing blocking the airflow really. So you would have tested the heater, test the components that should be working as they should, and once you're okay, then you have no other choice but to say it is the refrigerant that is the problem. When a refrigerator is low on refrigerant, then it cannot perform its cooling properties well. You may find one half of the fridge working and the other half is not working because it is just not enough, right? It will give some cooling, but it will not be effective enough. All right, so that is how we come to the conclusion. So you guys may not have seen how I added the refrigerant, but it's very simple. I will post the next video on how to actually recharge a fridge with refrigerant in the next video to come. What you will need is a manifold gauge. The right name for this is a manifold gauge. A lot of persons call it gas gauge, but the right name is a manifold gauge, right? So it would have two sides to it. You have a low side and a high side. The blue is a low side and the red is a high side. High side means a high pressure side, and the low side means the low pressure side. So this is a suction side of the refrigerator, and this is the push out side. This is the side that pushes the refrigerant out of the compressor and around to the coils, and this is the side that sucks it back in. All right, so it is added very simple, and I'm going to demonstrate that very quickly to you viewers and subscribers right here in this motor vehicle. I'm not going to release much refrigerant because it is not good and healthy to release refrigerant into the atmosphere, but I'm going to show you how it is done very quickly and simple. All right. Okay, so what we'd have done, we'd have get it, and we have the manifold gauge have three sections. You have the low side and the high side in red, and you have a middle section that you use to connect the refrigerant to. So what it does, it pumps it from the refrigerant can and goes up to the gauge and goes over to the low side, right? Because remember, we're going to feed the refrigerant through the low side, which have been connected to the valve we showed you guys earlier, that bullet valve that connect to the copper and would have been connected to the tubing of the refrigerator, which it would regas it through, or add refrigerant. So this is a refrigerant here, R1 34A, right? 340 grams. And the refrigerator hold about 120 grams. So we just added about half of that, about 60 grams, right? Because remember, refrigerant would have already been inside the refrigerator. We didn't drain it out. So you don't want to overload the system. So you would have added this by simply just, turning the valve of the refrigerant. I'm going to show you this real quickly. Right, and already you can hear that refrigerant coming into the lines. And what you do, you release the valve, right? And then that valve will start to go up, right? As soon as the pressure starts to rise. Now we don't want to release too much in the car now, so we don't turn this off, right? But that's what we'd have done it. You'd have added the refrigerant, and you turn it on, and it goes into the refrigerator. Sometimes what we do to really get it more into a liquid form, because the low side, it mostly have the refrigerant mostly in a type of mild liquid form, really. So you'd have turned it upside down to really get the refrigerant flowing in a semi-liquid form, really. Because you don't want to really see too much in the gassy state, because on the low side is more in a liquid state. So you either turn it upside down. That's why you see sometimes a person regassing or adding refrigerant to a refrigerator. They turn that can upside down in order to get the more liquid flowing into the line, more versus a gassy form. All right. So thanks for viewing, viewers and subscribers. I do hope this video helps. If you like it, give us a thumbs up and subscribe, and tell your friends and family about Greens Electrical School. This is directly out of Jamaica, and it is a good thing to have something like this coming from Jamaica. And I just encourage you to continue watching. If you have any questions or concern, you can always leave it in the comment below. I forgot to add something. Once you do the reading, you should get about a 60 or 70 reading on the gauge. Once your refrigerant is okay, and that's on the low side. On the high side, you get somewhere about 250 or 200 between here, or somewhere off here. That will be a completely normal reading. Okay, viewers and subscribers. See you next time. Mr. Green saying goodbye for now.